Hi folks, in this video we continue our discussion of reasoning from quantifiers. You'll reason from quantifiers not just in formal proofs, but also in informal proofs in everyday life. And so if you have some quantified premises like this, and you have to prove that some student will be happy, how would you do so in an informal proof? Pause your videos and see if you can write out how that would go in English. Okay, that was your chance to come up with an answer. Here's what I came up with. In order to reason from this existential information, I know there's some student who's going to get an A. I need some way to refer to them. So I just said, let's call them N. And I used N because in mathematics, this form of reasoning from existentials is incredibly common. And usually they use N or M, or sometimes even X and Y for arbitrary names like this. Let me tell you, in this class, I want you to use A whenever we're in a formal proof, just because we need a way so we're always doing them similarly and we're on the same page. So use A as long as the name A doesn't appear outside the subproof. But since we're in an informal proof, I'm just flagging the fact that if you've seen mathematicians talk about the letter N a lot, it's many times when they're doing this, talking about it arbitrarily. So I know somebody's going to get an A. I need a way to refer to them. I'm going to call them N. So I know N is going to get an A. N is a student who will get an A. But since all students from premise 2 who get an A are going to be happy, I know that N is going to be happy. I'm just instantiating this universal claim and doing modus ponens about my object N. Since N is also a student and they're going to be happy, I know that this conclusion holds. So informally speaking, you can go very fast. It's pretty obvious that this argument is valid. But the neat thing about our formal proof rules is they mimic this form of reasoning that we do in everyday life in our formal proof space. So when I box a constant like this for A, I'm doing the exact same thing as that mathematicians do when they say, call it N, or let N be so-and-so. And then they tell you what we know about N, like let N be some prime number between 0 and 20, or whatever the case may be. So when we assume A has some property, we always do this because we know some existential information about A. The structure of this formal proof rule for existential elim precisely mirrors the type of reasoning we do from quantificational existential claims in everyday life and in mathematics. So what you should be able to do is you should be able to give me a formal proof of that reasoning that we just did informally. I actually made the argument slightly simpler by getting rid of the student part. So just give me a formal proof of this argument. Pause your videos and see if you can write it out. Okay, that was your chance to pause your videos. It's great practice to force yourself to write these out several times and then check it with the answers. So here's how it works. What I did was just like that formal proof. Instead of using the letter N, I used A because we always want you to pick A first when you're dealing with formal proofs. And I know that A has something true about it, that namely they're going to get an A. After all, the reason I boxed that constant is because I have this existential premise up here. And once I'm talking about A, I just instantiated my universal quantifier. Now I have a wide scope error when I do modus ponens, and look at the step 6 is essential. I cannot stop the subproof at line 5 because I need to get rid of A. So existentially generalizing on line 6 is key. And notice this, the justification for these, the formula on 6 and 7 are the same, but the justification is different, and it's essential to understand why they are different. Okay, thanks.